Hello guys, welcome back to my channel Programming with a Purpose. This is the part 4 of the ClimateSense series. Here I am going to show you how to basically load a JSON file and your data that we have scrapped using Python into our app and show it on the map using MapKit. And also I am going to fetch some other data from another website that has earthquake data for 2023. So let's get started. So this website will be used to scrap the data of 2023 earthquakes. So as you can see that it contains a table and it has a TR in it. We are going to get it, and after that there are certain TDs that are relevant to the information we need from this website after scrapping. First of all is the lat long, which is basically the latitude and longitude. Both of these values have the same class, and after that there is a class that is mag or magnitude. We need that as well to scale down the intensity of earthquake. There is also an interesting parameter that is basically the depth, but the depth is not really relevant to the area of coverage. But if you want that value to be mapped as well, you can extract that value as well. And after that there are certain information such as location and an ID. If you click on the ID, you can get the detailed information of that earthquake. We do not need these two kind of information for now, so we are just extracting the latitude, longitude and magnitude for our purposes of filling the struct storm. So in the part 3 you have seen that I have created a scrapper.py script in Python, and in it I have scrapped a website of Canadian Fire Department. Now I am going to extract some of the earthquake data from another website. I have enclosed the previous code inside a type that is equals to fires, and when I am going to use the type is equals to earthquake, you can see that it will move in the else statement, and here I mentioned the URL. After that I am going to dig the tag tr, and tr will contain all the relevant tds. So we are going to get the lat long class, which is going to return us the latitude and longitude. So the first entry is the latitude, another one is the longitude. After that there is an area of coverage, but since there is no area of coverage for earthquake, so I have mentioned it is equals to 10,000 meters. After that there is a magnitude, which I am going to get and pass it to a function get intensity of earthquake, uh, which is going to get magnitude as a parameter, and after that it is going to return the intensity from 1 to 5. All of this earthquake data is said to be is expired because we cannot really predict the earthquakes in advance, so it will always be true. And after that we are going to write all of these values inside a JSON file with the name of sample underscore earthquake. So this is all for the changes in scrapper.py. So I am running the code inside the terminal, the Python script, and you can see that the script successfully runs, and it is going to create our sample underscore earthquakes file with all the relevant data. And we can open it and confirm that the structure is perfect using any of the JSON authenticator online. But while reading it, it is causing some of the issues. So for that purpose I have removed all of these backslashes with a replace and find functionality of Xcode, and it will take some time because the data is huge. It has 13536 matches, so obviously it will take some time depending upon the power of your machine. And after that, once it's done, you will see that the different elements are covered into different colors. So after that you will know that the data is properly set. Now we are going to combine the data from these two files, from the sample file as well as from the sample underscore earthquakes file. So it will contain the data of earthquake as well as fires. But before merging it, you should be very careful because we need to mention it as an array like a kind, and after that the values. So you can take some of the example from the here, and then you can easily merge it. So we need to pass the kind as well as all the values inside a curly bracket, and all of this data should be enclosed in a square bracket. So please take care of the format, and after that I'm going to show you how to read it inside a ClimateSense app. So now let's start coding. The step one is basically to add another struct inside the storm model file. You can modify the previous struct and change all of the code in all of the files. So avoid that hassle. I have created another struct which corresponds to all the values inside the JSON file. So it will have type, kind instead of type, intensity level, area of coverage is expired, and coordinates will be basically converted into latitude and longitude of type float. After that, I am going to show you the steps on how to import the file. That is basically a combination of two types of data, fires and earthquakes. And once you are done with the import of that file, you can see that it's properly imported. And after that, you are going basically to create another file with the name of read data. So read data will be a class, and we are going to read all of the data from our JSON file into our newly created struct. And after that, we are going to basically pass this data onto our content view. So follow all these steps. Here I am writing an helper function which is going to convert our int value of kind according to our storm type. So the function convert model will basically convert our storm JSON model to our standard storm model, and we are going to display that data inside the content view. So for that purpose, you have seen that I've multiplied the area of coverage with a value. This is basically to convert the fire data into meters. But since the area of the fire is usually not symmetric, it's not in circle, so we just give an idea of to the user that how much area can be effective. But usually the area is in rectangular form, and it is in acres, which is obviously in square meters, but we have basically multiplied it with and displayed it in the form of a radius of a circle, and our rest of the values are just converted into the relevant types and passed to the storm s. So you have seen that I have made it some of the changes inside the map view. This is basically to adjust the newly added data which is present inside the new storms data. And after that we are going to basically merge this data and also the static data that we are reading from the file populate data. And after that we are going to basically use the previous code. So I have changed the storms array to storms data so that we can additionally use the storms array to merge these of two arrays and pass it to the rest of the code. Here we are basically modifying the code of the map view delegate, which is view for annotation. And why we are changing it is basically once I've shown the earthquake data, the data was too much and the map was literally covered in broken buildings, which is basically default image to display the earthquake in our app. So I have searched for it how to basically reduce the data or to display it in a composed form. So for that purpose I came across the MK cluster annotation, which basically displays a lot of data in the form of a single annotation, and once we zoom into it, it is going to then split the data into individual annotations. So it is quite an interesting feature, and I have modified this function to cater to this thing. And you can follow all of these lines and add it, and then I'm going to play the code and show you how it works. So here I've missed a point, is basically I did not use the value of the variable s and appended it into a storms, because we need that value, otherwise content view will not be able to use these values. So add these lines and then play the code. So here you can see that since I have changed the variable name from storms to storms data, so we need to update that value here as well on line number 181 when we are creating a content view inside a var body sum view. So you can see that here I have played the code. You can see that this is the cluster image that I am using to display multiple disasters in that area. So once I am going to zoom it, you will see that it is going to be split into the different type of problems here. So basically it has split it into fires and earthquakes, and you can zoom it to the maximum level where you are able to see the individual annotations, and you can see the area where this issue is being seen. You can also, I have commented one of the line that is basically to display the area of coverage, because it is going to be too heavy for a lot of data to display and then display its area of coverage. So you can add this feature that if you want to show the area of coverage, then you can reduce the number of natural disasters in an area. And since the data is only for 2023 up to this 6 months, so it is a lot. If you want to show the data over a decade, so you really need to filter the data, or to find other means to render the map at a greater speed, maybe some GPU rendering or something like that. So this is how we are going to see the different type of natural disasters. Here you are able to see floods as well as earthquakes in a single area inside Pakistan. So guys, this is all for this tutorial. I hope you have enjoyed it. Maybe I'm going to add some other parts and some other data in the future tutorials. If you want any other features to be added to it, do let me know in the comment section. Please do not forget to like and share this video. Also subscribe to my channel to support it and to make some other interesting content for you guys. Stay tuned. Thank you for watching. Goodbye.